When we are asked to solve an equation like 2x plus 5 equals a negative 9, the first step is to model that equation using algebra tiles so we can see what's going to happen with it. So we'll start with our positive 2x. I'm holding the control key down as I click and drag. We need 5 1 tiles, positive 1 tiles. Making sure I have a plus sign, not an arrow key, which would make it larger. And then we need 9 of these negative 1 tiles. Now that I've got 4 of them, let's hold my shift key down so I can select more than one at a time. Copy 4 more, there's 8. Now we just need a single. I hold my control key down, that is. All right, so the first step is going to be to isolate the variable. We have 2 x's over here and a positive 5 with it. So let's do the opposite and add a negative 5 so that we have 0 pairs here. 1, 2, 3, 4, 5. But whatever I do to the left side of the equation has to happen to the right. So I'll hold my shift key down while I select them and make a copy. The nice thing is the 0 pairs go away and I'm left with 2 x tiles is equal to 2, 4, 6, 8, 10, 12, 14, negative 1 tiles. So if 2 of these x tiles equals 14 of the negative 1 tiles, then each x tile has to be equal to a negative 7. So let's work this using pen and paper. 2x plus 5 equals a negative 9 means isolate the variable by doing the opposite of adding 5. Subtract 5 from both sides. We are left with 2x on the left-hand side. 0 pairs cancel each other out, and we get a negative 14. Now, 2 is being taken times x. The inverse operation for multiplication is division. So we'll divide by 2. We divide the left side by 2, we divide the right side by 2, and x becomes negative 7. Solving 3a minus 4 equals 8 means let's change our variables to a and grab 3 of those positive a's. Now we need 4 negative 1 tiles. And 8 positive 1 tiles. Hold my shift key down to get 3 more. And let's make another copy of them, but remove 1 since we don't need 9. So again, the first step is to isolate the variables. We want to get the a all by themselves. So we want to negate these negative 4 tiles, which means we're going to add 4 tiles to the left-hand side. 1, 2, 3, and 4. But if we add 4 to the left-hand side, we have to add 4 to the right-hand side. So I'll make a copy of those 4, drag them over here. We've balanced the equation. So we are left with 3a's on the left-hand side and a total of 3, 6, 9, 12 on the right-hand side. If 3a equals 12, then each a has to equal a total of 4. Again, solving using pen and paper, 3a minus 4 equals 8. I have a positive 3a with a negative 4 added to it, so let's add a positive 4 to the left-hand side and do the same to the right. We're isolating that variable. 3a is now equal to 12. And 3 is being multiplied by a. The inverse operation for multiplication is division. If I divide 3a by 3, I have to divide 12 by 3. So a is now equal to 4. In the final example, we have 4 positive 1 tiles. And we're taking away an m over 2, so we get a negative m tile, but that negative m tile is split in half. And that's going to be equal to a positive 6 on the right-hand side. So here are 6 tiles, 6 1 tiles. Now, first of all, to get this negative m over 2 by itself, we're going to have to add 4 negative 1 tiles to the left-hand side. So there are 4 negative 1 tiles. But if we're doing that to the left-hand side, we have to perform the same operation to the right-hand side. So there are 4 negative 1 tiles on the right-hand side. The net result is going to be a negative m over 2 on the left side and a positive 2 on the right-hand side, because the 0 pairs will disappear. So what this is saying is m is being split into 2, and its value is a positive 2. So if we want to get a full negative 1m tile, we have to double what's on the right-hand side. So we would get a total of 4 on the right-hand side when we have a full negative m tile. And if a negative m is equal to a positive 4, that means that the opposite of negative m is going to be the opposite of a positive 4. So m will be equal to a negative 4. So here's the algebraic method. 4 minus m over 2 equals 6 means isolate this negative m over 2 by doing the opposite of having a positive 4 here. The opposite of a positive 4 is a negative 4. Balance the equation by adding a negative 4 to the right side as well. And when we add up 4 and negative 4, 0 pairs go away. Negative m over 2, don't lose that negative sign, is now equal to a positive 2. Another way to think of that is there's an understood 1 here. This is a negative 1/2 m, and that's equal to a positive 2. So what is the opposite of multiplying by a negative 1/2? Let's multiply by a negative 2 over 1. If I multiply the left side by a negative 2, to multiply the right side by a negative 2. And a positive 1m is now equal to a negative 4.